Okay, so welcome back, and here's the third act of our tutorial on simplex, and we are going to talk about pivoting. Pivoting is the most important operation, and we are going to talk about this in this.
So let's first look at the operation of pivoting from 2000 feet. So this gives you a very good overview of what pivoting is all about. So what does pivoting involve? Before we start describing pivoting, let's look at what a prototypical dictionary looks like. So here we have a dictionary. So this dictionary has variables xb1 through xbm, and these are the basic variables. And you have some non-basic variables xi1 through xin. Okay, and this is how a dictionary looks like. Great. So there are n non-basic variables, and there are m basic variables. And the one invariant that simplex always maintains is, in any dictionary, the number of basic variables, m, is the number of constraints in the original problem, and the number of non-basic variables, n, is the number of decision variables in the original problem before we added slack. And this is maintained as an invariant throughout simplex. So pivoting involves the following steps. First step is we are going to choose a variable xij. It's actually going to enter the basis, and it's called the entering variable. So the entering variable is going to go from here to here, from being non-basic to being basic. Okay, so if that were to happen, then what will happen is there will be m plus 1 basic variables and n minus 1 non-basic variables, which is not allowed. Therefore, we have to choose a leaving variable, a variable that's previously in the basis that needs to leave the basis and go back here. Okay, and so what we do is we reorganize the dictionary. So xij ends up here and xbk ends up here. And this process of reorganizing the dictionary is called pivoting. Okay, therefore to summarize, pivoting involves three steps.
Choose an entering variable. For the choice of entering variable, find a leaving variable and perform substitutions to obtain the next dictionary. 3 steps, and with these 3 steps, you will be the absolute expert in pivoting. So let's get there. Alright, so this is a problem that I took from the book Schwartal chapter 2. So if you have a copy of the book, you can follow along. If not, no worries. The slides are all here and everything you need to know is on the slide. Okay, so the problem really doesn't matter. So this is the problem. Okay, we quickly go ahead and make up a dictionary. All right, and in this case, through some magic, this dictionary is feasible. Okay, so I'm not going to talk about how to deal with infeasible dictionaries right now. We'll start with a feasible dictionary and explain pivoting on feasible dictionaries. We'll talk about infeasible dictionaries in the next lecture. Okay, so to keep your focus, here's the original problem, here is the dictionary. And if you have been following me all along, then there is no magic that's going on here, just a series of steps to get me from here to here. Okay. Solution associated with this dictionary is x1 equals x2 equals x3 equals 0, x4 equals 5, x5 equals 11, x6 equals 8, and the objective z in this dictionary is 0. And remember, z needs to be maximized. Right here it says z needs to be maximized. Okay, so we are all set. Keep this all in mind. Let's move. Alright, so in this plot I have shown you that x1, x2, x3 are currently 0. Okay, x4 is currently at 5, x5 is currently at 11, and x6 is currently at 8. Okay, now the process of pivoting is going to choose one of these 3 guys, x1, x2, or x3, and we are going to try and increase it. Why are we going to increase it? Well, notice that z depends on x1 positively. So z is 5 times x1 plus 4 times x2 plus 3 times x3. So if we increased x1, then z is also going to increase. If this were minus 5, that wouldn't be the case, but since it's plus 5, if x1 goes up, then z goes up. Likewise, if x2 can be increased, then z increases. Okay? If x3 can be increased, then z increases. So to increase the value of z, because my objective of the problem is to maximize the z, take it up, right? If I have to maximize the z, then I should do so by increasing x1 or increasing x2 or increasing x3. Okay? And one more thing to note is that since we have x1 greater than equal to 0, x3 greater than equal to 0, there is no objection to increasing these things, because increasing x1 is not going to violate any of these constraints. So you are perfectly within your rights to be asked to increase x1 or increase x2 or increase x3. Okay? So in this case, either of these three variables can be an entering variable. So what's the definition of an entering variable? Well, it's a variable whose increase increases the objective. Any such variable can be an entering variable. And this is your choice. You are free to make a choice in this case between x1, x2 or x3. Any of these three can be entering. Okay, so let us choose x1 with arbitrarily. We'll just make a choice and we'll say let's choose x1. Let's go ahead and take x1 all the way up, as far up as we can take it. Okay, alright, so you may say, let's take x1 to infinity, and z will go to infinity, and infinity is bigger than anything, right? So why can't we do that? Well, before we do that, let's look at formally the rule for the entering variable and then answer the question why we can't do that. Okay, so what is formally an entering variable? Formally, you look at the dictionary and you say an entering variable is one for which the coefficient in the objective row Cj is positive. What does that mean? What that means is if the corresponding variable increases, then z increases. If Cj is negative, then if xj increases, then z will decrease. And we do not want that. We do not want to decrease j. And so we say that if the corresponding entry here is positive, then the variable can enter, can be a candidate for entering. Okay, so we'll keep this in mind and come back. Okay, but now let's go back to the burning question, which is, suppose I chose x1 to be my entering variable. Okay, choice is made, we are going to do that, and I want to increase x1. Okay, so currently in my current solution x1 is at 0 and I want to take it all the way up. Okay, so you could say, let me choose x1 and take it to 100. What stops me from doing that? If I took x1 to 100, then correspondingly z becomes 500, which is very good. I'm trying to maximize z, so I should keep x1 as high as possible. On the other hand, here we have x2 and x3 set to 0. Okay, and since these are not entering variables, they are going to remain 0. While we do this exercise on x1, x2 and x3 are just going to remain where they are. We are not going to do two things at a time, we are going to do one thing at a time. Okay, so if they are going to remain 0, I'm just going to forget it, because these two rows are going to contribute nothing to my calculation. Okay, now let's just focus on the part that matters, which is the entering variable and the constant. Okay, so suppose x1 becomes 10. I take it up to 10. Then what does x4 become? So x4 is 5 minus 2x1, and this becomes 5 minus 20, which is minus 15. Okay, so if I take x1 from 0 to 10, x4 unfortunately falls from 5, which is its current value, to minus 15. Okay, and that's not good, because minus 15 is less than 0 and x4 greater than equal to 0 constraint is violated. Alright, so there has to be a limit to the increase, and the limit comes from the fact that if you increase x1, some of these variables may start to decrease, because this coefficient may be negative. If so, then they are going to start to decrease, and therefore the increase can only happen until any of these guys will touch 0. Okay, so how much can x1 go up? So x1 can go up from 0, and you can take it up to around x1 equals 2.5, and when you do that, x4, which starts from 5, starts to decrease, and when x1 is 2.5, x4 is 0. Okay, likewise look for x5. Well, x1 starts at 0 and it can go all the way up to 11 by 4. Okay, so it can go up to 11 by 4, and when it goes to 11 by 4, it stops. Okay, because x4 on the other hand, x5 on the other hand, which starts at 11, okay, goes all the way down to 0. Right? Likewise, x1 can start at 0 and x1 can go all the way up to 8 by 3, okay, before x6 becomes 0. Alright, so each of these variables, x4, x5 and x6, places their own constraint on the increase of x1. Okay, so the question is, which one becomes negative the fastest? Okay, and when you find that out, you have also found the variable that has to leave. Alright, so let's look at this. So if you look at this, then you say, well, if x1 is increasing, that's our choice of entering variable. You can keep increasing x1 and x4 is happy as long as x1 is less than or equal to 5 by 2. Why is that? So you say x4 greater than or equal to 0. In other words, you say 5 minus 2x1 greater than or equal to 0. Remember, these guys are non-participants because these are just 0. Okay, and therefore, what you have is x1 less than or equal to 5 by 2, which is the constraint you obtain here. Same analysis gets you x1 less than or equal to 11 by 4. So 5 by 2 is around 2.5. 11 by 4 is 2.75. Okay, 8 by 3 is 2.66 bar. So it's just 2.66 forever. Okay, so if you think about it, as long as I can keep x1 below 2.5, x4 remains non-negative, and x5 can remain non-negative for a longer time until 2.75, and x6 can go somewhere in middle up to 2.66. Right? So the critical guy here is x4. You can take x1 up to 2.5 and no more, because when you take it beyond 2.5, x4 is the first one that hits 0 and goes below 0. So x4 is the critical guy. Okay, so therefore x4 is the leaving variable. So you can increase x1 and you can increase it up to 2.5, no more, and when you hit 2.5, x4 hits 0. So x4 will come here and x1 needs to go here. Okay, so the dictionary will change. x1 is entering, and corresponding to x1, x4 is the leaving variable. Okay, so this is a very simple analysis, and it can be automated, but right now we are doing it by hand.
Okay, so we've reached a nice point where we now know how to choose the entering variables for the linear program, and corresponding to the choice of entering variables, how to find leaving variables. Okay, so now that we have seen all of this, there is one last step that's the most important step, and that's the step of pivoting. Okay, so the pivoting is the third step where we have to perform substitutions to obtain the next dictionary, and this is going to be the topic that we will see in the very next video, and I'll see you there, and thank you.